We ready? Are we live? Okay, hey, welcome back. Second part for this lecture for section 2.2. In the beginning, the first problem we did was a little simple. You had an actual number, a point. You had like a value to begin the problem with, and you plugged it in, and you found the answer. Now we're going to just kind of keep it more general. This is problems 3 through 12. So you're going to try to find F composed with G and then G composed with F. So you're going to have to flip it. And they want us to identify the domain. So a little bit going on here. I'm going to start with one of the hardest problems, number 9. So hopefully, if you understand this one, you'll be able to do number 3 and 4. Those are a lot easier. So we've got our two functions. F of x is 2 of x over 4 minus x. And we've got g of x is equal to 1 over x squared. That's the first thing. So to attack these problems, before you start getting into your composition stuff, the first thing is you want to find the domain, especially of the one that's first. So let's start with this one, f of g of x. So I'm going to remind myself, because I don't like that form so much, that little dot, so I'm going to rewrite it. I'm trying to find f of g of x. So I'm going to find g of x, plug that into f of x. So it's very important to know the domain of g of x. Remember, the domain are the numbers that, the inputs, the ones that are allowed to go to g of x. So let's just look at g of x by itself first. What do you notice about this? Are there any restrictions to the domain? And I'm going to just kind of write this on the side. Well, since this is going to be x squared, whatever I put in there is going to become positive. But there's one number. Remember, whenever you have, for calculating or determining your domain, whenever you have an x in the denominator, you have to make sure that the x never becomes 0, because you cannot divide by 0. So there is a restriction. X cannot be 0 for this function. And since this function is going to go inside of the bigger function, then we have to remind ourselves that, because when we get the final answer, the x may not be in the denominator anymore. So it may look like the composed function that 0 will work, but in reality it can't, because the whole thing started with g of x. So if it doesn't work with g of x, if there's a restriction here, then you can't even put it into f of x. All right, you just have to kind of break it down. So the first step is just say that x is not 0. Other than that, all real numbers. All right, x is an element of all real numbers except for 0. And I believe that's it. So now we've got that. Now what we're going to do is algebraically take the function 1 over x squared and plug that in to the f of x. So where do you put it? How do you know where to put it? You put it, remember, this x and this x are not the same thing. Just think of this x as like the container. So there's two of them. There's one here and one here. This container, you're going to put this whole function, whatever this function is. This one's pretty hard. The other problems are easier. But whatever that is, you're going to stick it into that container and into that container. And then you're going to have this big old algebraic mess, and you're going to have to clean it up. So let's go ahead and do that. So that's going to be 2 times all that, 1 over x squared. That's going to be in the numerator. And the denominator is going to be 4 minus 1 over x squared. So far, that's kind of nasty. Don't panic. Let's go ahead and do some of our algebra. So I'm going to multiply that. We got a fraction over a fraction, right? Fraction divided by fraction, stuff you guys love. So that's really going to be 2 over x squared on top. That's not so bad. Now on the bottom, we need to have a common denominator. Right now that's 1, right? So it's not too bad. I'm going to do this kind of orally and in my head, and then you guys write it out on paper. So x squared is going to be the common denominator. So I'm going to erase that. I'm going to put in x squared on the bottom and an x squared on top, right? Because those two x squareds are really going to cross off, and you're going to come back to a 4. So it's really 4x squared minus 1. So the fraction on the bottom is 4x squared minus 1. There's the 4x squared minus 1. And then the denominator is x squared. All right, so we're getting closer. Fraction over a fraction. Looks nasty, but just go back, old school it. I'm going to erase this other part. So I'm going to write the first fraction here. I'm going to remember that's really a division sign. So when you divide fractions, you multiply, right? And then you find the reciprocal of the other fraction. So that's the reciprocal. I should write that as a dot, shouldn't I? So you don't confuse your x's. The reciprocal x squared over 4x squared minus 1. And lo and behold, they've been kind to us. Boom. Cross simplify. Those two will cross off. So now I have a new function, 2 over 4x squared minus 1. Voila. That's the final function. That's after I took the g of x, stuck it inside of the f of x, did all my algebra, and out popped the new composed function. I think that's how you'd say it. The function of the composition between f and g. And then the second part is what's the domain. So now we look at this and we say, uh-oh, we got another x down here. We can't let this whole thing in the bottom turn to 0. So there is going to be some more restrictions for this one. So when will this equal 0? Well, let's set it equal to 0 and find out. 4x squared minus 1 equals 0. Put the 1 over. 4x squared equals 1. Divide by 4. X squared equals 1/4. Oh, I might get my little drawing on the way. And then take the square root of both sides. What's the square root of 1/4? Don't freak out. Don't turn it into a decimal. Just think about it a little bit. You know, you could do your whole thing, square root of 1, square root of 4, or just kind of think in your mind, well, 1/2 times 1/2 is 1/4. So the square root of 1/4 is going to be plus or minus 1/2. What does all that mean? Remember, remind yourself that if x were 1/2, that'd be 1/2 times 1/2, that's 1/4. 1/4 times 4, that's 1. 1 minus 1, that's 0. So if x is 1/2, this will turn to 0, and that will give us a null answer, because you can't have a 0 in the denominator. So for your final domain, you cannot let x equal 1/2, positive or negative, right? Because if you put in negative 1/2, the same thing happens. Negative 1/2 times negative 1/2 is positive 1/4 times 4, and so on. So those two cannot work because they don't work in the final, where it is, in the final composed function, right here. And don't forget, before we began, you had to check the very first function and see if there were any restrictions there. And there was one restriction. X can't be 0. So both of those to find your domain. And then other than that, x can be anything. X is all real numbers. I need to get a bigger board, so I have to keep erasing, especially for these problems. So that's a doozy. That problem is one of the hardest ones. Number 10 that's the one you have to do. That's probably maybe a little harder than that one. I don't know. Take your time with it. But the important part, people like the steps. Step 1 is you wrote out your two functions. You figured out the domain for the one that's inside function, right? The g of x, because it's inside the loop. Then you plugged it in, you did all your algebra, and then you figured out the domain a second time, and you combine those two together. So that's just the first part of the problem. Then they want us to do that whole problem over again, but this time they want us to do g of f. So then we would do this one first, because the f is inside now, and we would have to say, what's the restrictions here? So I'm not going to write it all out, but just think in your head. The restriction here is you can't let this x be 4, because if 4 minus 4, that's 0. So that's one restriction. Then I would take this, I would plug it in over here. All of that would plug into the x squared. You'd have to square it out, do a lot more funky algebra, and it actually comes out cleaner, I think, than the other one. So if you want to try that, try that. Remember, you have the worked solutions in the book, but in the book, he doesn't go through all this algebra. I guess he thinks that's trivial, and you should be able to do that. But it's obviously very hard. So take your time and be neat with your writing, and then let me know if you need help.